Unit 10, Day 9, Solving Logarithmic Equations continued. This is Mr. McGough up in R12, and first we're going to go over a little bit of review. We're asked to solve x squared minus 16 equals 0. This is a difference of squares. So we get x plus 4 times x minus 4 equals 0. From there we use the zero product property, so we know that one of these must be 0 for the product of these two factors to equal 0. So either x equals negative 4 or x equals positive 4. Solve x squared minus 3x plus 2 equals 0. This is a trinomial, quadratic trinomial, so we know that we can solve by doing a times c on the top of our x, negative 3 on the bottom of our x, or b. And we want to find two numbers that multiply together to positive 2 but add together to negative 3. So both of them must be negative, and what they are is negative 1 and negative 2. My leading coefficient is 1, so I can write my factorization to x minus 1 times x minus 2 equals 0. Again, zero product property. If either one of these two factors equals 0, then our product is 0. So, in this case, either x equals 1 or x equals 2. State the end behavior of this function, 4 times 3 to the x plus 5. Well, if x is a large negative number, this becomes 4 times 1 over 3 to a large negative number, like 1,000 or something. And then we add 5. Well, what's happening here? As this exponent gets very large and very negative, my number on the bottom, it becomes 3 to the positive version of that exponent. That's a very large number. 1 divided by a very large number approaches 0. 4 times a number approaching 0 is still approaching 0. And then we add 5. So, as x approaches negative infinity, f of x approaches 5. The other side's a little easier. As x gets to be a very large number, 3 to the power x becomes a very large number. And in fact, as x approaches positive infinity, f of x also approaches positive infinity. Now into the new work for day 9, applying this sort of concept to solving logarithms. We learned about the product and quotient rules as well as the power rule for logarithms. Here we have two logs of the same base. So we know that when we're adding these logs together, what that really means is it's the log base 2 of x minus 1 times x plus 1. And that's going to be equal to 3. So x minus 1 times x plus 1 is x squared minus 1x plus 1x, so the x term goes away, minus 1. So log base 2 of x squared minus 1 equals 3. Now we know that log base b of something equal to a number means that the base raised to that number, that is, so it becomes 2 to the third power equals x squared minus 1. Well, 2 to the third power is 8, so I'll subtract 8 from each side to set this equal to 0. So I get 0 equals x squared minus 9. This we recognize as a difference of squares. So that is x plus 3 times x minus 3. Zero product property says one of these must be 0 for the product to equal 0. So x can either equal negative 3 or it can equal positive 3. But looking back up at our problem, log of x minus 1. If x is negative 3, I would be trying to take the log of a negative number, and 2 raised to a power will never become negative. So the negative 3 is not a valid answer. It's an extraneous solution. So our answer is just x equals positive 3. For our next problem, we have 3 log base 2 of x minus 1 equals 5 minus log base 2 of 4. Well, first, log base 2 of 4 does not have a variable in it. So it is just going to be a number. What does log base 2 of 4 really mean? It means that 2 to the x power equals 4. What power would that have to be? 2. So we know that this right side is 5 minus 2, which is 3. On the left side, 3 log base 2 of x minus 1. So now we're going to divide each side by 3, and we get log base 2 of x minus 1 equals 1. So looking at our rules again, what does this mean? It means 2 to the first power equals x minus 1. 2 to the first power is 2, so I'll subtract 2 from each side to set my equation equal to 0. I get x minus 3 equals 0. So add 3 to each side, x equals 3. Problem number 3. Log of 2x, which, by the way, log is the common log, base 10, plus log of x minus 5 equals 2. Same base, so we can apply the product rule to these logs. What it really started out at then was log of 2x times x minus 5 equals 2. And I'll write the 10 down there, even though I don't need to. But that's so we can take a look at what's really going to happen here. We're going to use our rule of our basic definition of logarithms, and this means that 10 squared, 10 to the second power, equals 2x times x minus 5. So 100 equals 2x squared minus 10x. Next, we're going to subtract 100 from each side to set our equation equal to 0. And then we're going to take out our greatest common factor and factor the rest. So 0 equals 2 times x squared minus 5x minus 50, which equals 2 times x plus 5 and x minus 10. If you need to, you can go through the process of factoring that on your own. So what do we know? 2 times 2 different factors equals 0. So one of the factors must equal 0. So either x equals negative 5 or x equals positive 10. We're looking back at the equation. Negative 5 times 2 would be negative 10. We can't have a log of a negative number. So that is an extraneous solution, and our only good answer is x equals 10. Log base 4 x plus 9 plus log base 4 of x equals 2. We're going to use that same process again. So log base 4 of x times x plus 9 equals 2. Or 4 squared equals x squared plus 9x. 4 squared is 16, so we'll subtract 16 from each side. And we get 0 equals x squared plus 9x minus 16. Now, you can try, but this is not factorable. So how do we solve a quadratic equation that is not factorable? We can either graph it, or we can use the quadratic formula. The quadratic formula, x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. So b is 9, negative 9. Plus and minus the square root. B squared is 81. Minus 4 times 1, which is a, times c, which is negative 16. Negative 4 times negative 16 is positive 64. And all of that is divided by 2 times 1, 2. So we look back. Log base 4 of x is part of our problem. So I cannot have negative 9 minus something. That won't work. It'll give me a log of a negative number. But I can do negative 9, and I'll move this up here, negative 9 plus the square root of 81 plus 64 is 145, divided by 2. Looking back at our instructions, it says round to the nearest hundredth. So in our calculator, we're going to have negative 9 plus the square root of 145. Oh, that's times. Negative 9 plus the square root of 145 divided by 2. 1.52 to the nearest 100th. Problem number 5. So here we have, let's see, what do we want to do? Number 5. Well, the first thing we're going to need to do is subtract. Well, oh, look, they're all the same base. So I'm going to subtract log of 2x plus 3 from each side. So what do I get? I get log 5x plus 1 minus log 2x plus 3 equals log of 2. So when I have subtraction, I use the quotient property. This is log of 5x plus 1 divided by 2x plus 3 equals log of 2. So I have a log base 10 of one thing equal to the log base 10 of 2, which means the thing is equal to 2. So what I can do next is I can say 5x plus 1 divided by 2x plus 3 equals 2. I'll multiply both sides by 2x plus 3. So I get 5x plus 1 equals 4x plus 6. I'll subtract 4x from each side. I'll subtract 1 from each side. I get x equals 5. By the way, with all these ones that have a common log, you can actually put your number back in for x and check your work directly with your calculator. So this would be log of 26 equals log of 13 plus log of 2. You can check that on your own. Number 6, I have plus. Plus is part of our product rule. So this is log base 2 of x times x minus 7 equals 3. Going back to our rules again, this means that 2 to the third power equals x times x minus 7. So that means that 8 equals x squared minus 7x. I'll subtract 8 from each side. And then I'll factor. I need two numbers that multiply together to negative 8, add together to negative 7. So those numbers are positive 1 and negative 8. So I get 0 equals x plus 1 times x minus 8. Zero product property, one of these must be 0 for the product to be 0. So either x equals negative 1 or x equals positive 8. Looking back, if I had negative 1 minus 7 is a negative number. So negative 1 is no good, extraneous solution. My only real answer, x equals 8. Problem number 7. Log of 5x plus log of x minus 1 equals 2. Same process. Log, by the way, this is base 10, of 5x times x minus 1 equals 2, which means 100, 10 to the second power, equals 5x squared minus 5x. Subtract 100 from each side. I will remove my greatest common factor. And then I will factor. So either x equals 5 or x equals negative 4. Looking back, I can't have a negative log, so x equals 5. For problem number 8, woo, that looks like a long one. Let's break it down. So log base 9 plus log base 9 equals log base 9 plus log base 9. So that means that on the left, log base 9 of x plus 7 times x equals, on the right, log base 9 of 2x times x plus 5. Now these are both log base 9. That means if they're going to be equal, the stuff inside on the left has to be equal to the left inside on the right. So that means x squared plus 7x must equal 2x squared plus 10x. So I need to set this equation equal to 0 to solve, so I'll subtract x squared from both sides, and I'll subtract 7x from both sides. And I get 0 equals x squared plus 3x. When I factor this, 0 equals x times x plus 3. Zero product property. X is either equal to 0 or negative 3. But looking back, 2 times 0 is 0. I can't have a log of 0. 2 times negative 3 is negative 6. I can't have a log of a negative number. So the answer is no solution. Hope that helps, and I'll see you all in class.